Hi, everyone. Thank you for making the time to join us on this webinar on improving insurance underwriting without draining IT. It's great to see so many familiar faces with us here today. I just want to extend a thank you to the community for all your questions, comments. And without further ado, let me hand over to Goli for a bit of housekeeping.
Absolutely. I'm waiting for Rash to bring up actually the slide, Adrian. Yeah, that's actually coming up. That's fantastic. Thanks, Adrian. Thanks for everyone joining us today from different time zones. We are super excited to see you. My name is Goli. I'm the VP of Customer Success at FlexRule, and I have Arash with me. Arash is the FlexRule founder. Just couple of housekeeping items. There is a Q&A box on the bottom of the Zoom that you can put all of your questions, and we allocated 15 minutes at the end of the webinar to actually go through your questions. And also, we are recording this session. If for any reason that you need to jump off, we have your email address, and don't worry, we will send you the recorded session later on. Fantastic. I'd like to start with the brief couple of seconds to just tell us who we are. We are FlexRule, headquarters based in Melbourne, Australia. Our mission is to empower all leaders, business, operation, and IT to organize IT and organization to improve speed and quality of key business decisions in changing environments. Proudly, we have customers around the world, North America, Europe, and of course APAC, and very interestingly across a wide range of industries such as insurance, finance, leasing, government agencies, and etc. Fantastic. With no further ado, to start our exciting webinar, I'm handing over to Arash. Arash, stage is yours.
Excellent. So, in this webinar, this is one of the series of webinars we want to run based on the industry requirements. And what we're going to do is we started with insurance and we get to other industries very soon. So let's get it started. We're going to talk about how insurance organizations can use advanced technologies without draining IT. And based on the understanding of us from insurance, there are very heavy reliance on IT. And in this webinar, what you will learn is how to still have the IT as the support and backup plan, but how you can get things done, create decisions, automate business roles, deploy them and operationalize them as part of organizations' processes and systems without draining the IT. So insurance is a complex business. It's betting against odds, uncertainties, disasters, wars, pandemic, cancer, earthquake, tsunami, car crashes, and whatnot. Now, the insurance providers running this business by balancing the risk, taking calculated risk, contained risk. Things are not risk-free for neither parties, clients, nor providers. And there are guidelines in insurance organizations to help them to reduce the risk or take the calculated risk within their risk appetite. These guidelines are often called rules book, and the role of underwriters are to put this rules book into practice to identify a situation, assess the risk, and take the next action. Rules book, as the name suggests, are driven by business rules. They are a set of business rules that guide the underwriters to make decisions on what is accepted, what is not accepted, what's the next step in a given situation, and what extra information they require to proceed. Here's a couple of examples. In a car insurance scenario, you may or may not be eligible for a discount based on whether or not you have had an accident in the last 5 years of your driving. Or your application might be declined if you're under 25 and you've had a speeding ticket last year. And these are just some examples, right? These examples are across many different types of insurances, from general insurance, health, business, properties, casualty, and so on. For instance, based on your insurance provider, you might need to be a citizen or legal resident of a country when you're seeking for a health coverage. As we see in these examples, business rules are guiding underwriters and help them to shape their judgment about a particular case in a very specific situation. But here is the pickle. Where there is a judgment, there is a noise, more than what we think. Noise by Daniel Kahneman is a book that explores the psychology of decision-making and how people's decision can be influenced by their environments. This book shows how the brain is wired for noise, and human judgment is influenced heavily by factors such as cognitive biases, mood, group dynamics, emotional reactions. And as the leaders of organization, it is our duty to make sure we can combat the noise. Because if we don't, the result is the decisions are biased, inconsistent, inaccurate, based on gut feeling, influenced by personal moods. And this is a disastrous result for any companies, in particular insurance companies. Insurance providers generally want to have a quick act decision, which is quick, accurate, consistent, and transparent. A study shows from the Insurance Information Institution that 31% of policyholders would switch insurance companies if they were unhappy. And within the range of the certain range, that percentage is even can go to 44%, switching insurance providers if they are unhappy. And you can see the direct association between the bottom line and market share from insurance provider to the quick act decisions that they make as part of every process they run. The good news is, though, there is a very effective way to combat the noise. The most effective way to combat the noise is to build algorithms running by machine. And the key advantage of running algorithms on machine is that they're noise-free. Unlike human, the formula will always return the same output for any given input. They cannot be influenced by cognitive biases, mood, group dynamics, and emotional reactions. And I better be super clear, when we're talking about algorithm, we're not talking about Skynet, Terminator, or ChatGPT, or large language models and of any type of these AI techniques. Let me explain quickly for the people that they're not familiar with algorithms. An algorithm is a recipe for a computer to know how to make a decision. And it's been long known that prediction and decision made by algorithm are often more accurate than these made by experts, even in the time that experts have more information in their hand. And there are different types of algorithms. There are deterministic, probabilistic, and what we're talking about algorithm here is generally statistical and rule-driven algorithms. For example, there are many scenarios in insurance companies and insurers that this type of algorithm, as I mentioned, based on the rule books and the decision they make under the underwriting team, that is the big significant part of the algorithm they use. For example, pricing, rating, discount, eligibility, and list goes on. Let's say in car insurance, you provide the policy, and this particular algorithm for pricing can calculate the pricing for insuring a car based on the driver behavior in the past and general health information about the particular car. There are different ways to build these algorithms and integrate them into organization systems and processes. However, the big difference is how much of software development and IT you require to build, test, deploy, update, and maintain the algorithms. Considering the fact that dealing with algorithms and business rules and rules-driven decisions is not only about updating a number, and you need to keep them updating based on rules and regulations, law and regulations, product configuration, in many different scenarios, new product launch, customer segmentation, and so on. You need to be able to choose the right approach for your team and for your organizations to make sure you're able to constantly tweak, improve, and enhance these algorithms. The first approach to build and automate these algorithms and run them on machine is using a generic purpose programming language such as Java and .NET or even RPG on AS400 or COBOL to build these algorithms such as car insurance and make them deep into systems and processes and make them automated. The benefit of this approach is if you have software development in your organizations and IT, you can leverage that and build these algorithms. However, this approach lacks the agility and flexibility to manage decisions in a convenient and intuitive format that can be understood with domain experts. Because of the nature of this approach, which is purely software development and IT driven, these decisions are inflexible, potentially unprofitable, and fail to meet policyholder expectations, and 100% reliant on IT and software development teams. The second approach is to use business rules management system or business rule engine. We're going to talk about that in a minute. In this case, the benefit is rules can be easily changed and can be easily understood with domain expert and operation team because the way they are modeled are using different techniques of rule modeling, might be a decision table, might be a natural language. At the end of the day, they do not need to know anything about programming languages and how computers work in terms of how you can specify an algorithm to a computer to run that. Depending on the adoption of the solution, you might see that it goes beyond the small group and might be spread across multiple groups and teams, and domain experts and operations start building and testing business rules. The challenge with this approach, though, is because of the nature of this approach that you tend to manage business rules, there will be too many of those rules to manage, and that will result to bad behaviors. It becomes too complex, and to manage this complexity in business rules management system, you will have something like rule labeling, rule tagging, rule grouping, different things to identify what is this rule in this system is going to do. Because when you focus to rules, you lose the context of the decision. And they are too granular and too small and too much details around them. And this is a significant drawback of business rules management system. Besides the fact that you still need a lot of help from IT and hand-holding for data preparation, data ingestion, data integration, deployment, service management, orchestration, and putting the result back into organizational systems and processes to make things happen and change the organizational behavior. And as you can see, based on the lack of these capabilities and focusing only on rules, you still will need a lot of help and handholding and involvement from software development and IT. As a side note to this, when we're talking about also business rule engine, or you will hear BRE, BRE is just a component as part of the overall solution for business rules management system, which is generally tend to become a component in software development team to change things easier. Generally, if it is BRE approach, it doesn't go beyond the business software development team, and it doesn't become a primarily approach to model rules outside of IT. And the third but not least approach is decision management suite. Traditionally, vendors from this space coming from business rules management system, and the benefit of doing this is not focusing on rules, very different from the rules approach, focusing instead on the decision. And as soon as you focus on decision, good things happen, because now rules have a context about a particular decision they're contributing. Though you need to make sure when we're talking about decision management suites, there are many, many different ways that you can approach this. Some vendors simply just renamed a rule set to a decision, and that's how they did it in this particular scenario. But there are characteristics that you can see in the behavior. It's entirely different entity when it comes to organizations. For instance, decision by nature can be hierarchical. Decision by nature can involve rules and some other types of algorithms. In the other side of the coin, business rules management system, rule set is a collection of rules, and that's only what it is. Decision can be collection of multiple combined algorithms from rules and statistical algorithm, and we're going to talk about that in more details soon. Now, the other benefit of focusing on decision is that there are standards around the decision. Now, there is a standard called PMML for predictive modeling. Statistical models can be imported as part of your decision-making scenario, or there is a standard for decision and rules modeling and execution called DMN. And these standards enable you to do a better interoperability and portability when it comes to decision execution. So you can build somewhere else, execute it in anywhere that you want. However, with everything good about decision management suite, there is lacks in certain areas. For example, cross collaboration. A decision management automation project is a very involved project. You need different skills, you need different team members. Cross collaboration is a very core component to make sure you success in implementing and deploying decisions across organizations. Decisions are hierarchical and can be long running. So decision management suite traditionally, they don't support hierarchical and long running decisions. Data services and application connectivity, as well as data preparation and building query for non-technical team member, are lacking decision management suites. Decisions are not run in vacuum, and the result of them should be integrated back into organizations, systems, and processes. Therefore, you require orchestration, which is lacking in decision management suites. Capabilities around test, simulation, impact analysis, live debug are very limited. And tooling around operationalizing, monitoring, measuring decision performance are lacking as part of the decision management suites. Which all of these lacking capability and weak spots in decision management suite ends up involving software development team and IT teams to build on top of what decision management suite can do to enable the teams to literally deploy these decisions to organizations. To address these needs, we need to look at the whole process of decision automation and management effort and provide tooling across all the stages of the process rather than just focusing on modeling and executing a decision. And to do that, we need an end-to-end decision management suite, which is the next generation of decision management suite, empowering non-technical team to manage, automate, deploy, integrate decisions at scale by pushing the boundaries of traditional decision management suite. That provides a unified tooling around everything your team needs to manage decision, cross-collaboration, integrated and built-in decision orchestration, automation of complex, hierarchical, and long-running decisions, as well as simulation, impact analysis, and understanding change of rules within the scope of the decision. And this unified, integrated, simple platform empowering you to build a lean, agile, small, self-sufficient team to be responsible to identify, automate, operationalize business decisions and integrate the result back to processes and systems without relying too much, and in many cases, no dependency at all to software development teams and IT. And the way it works is you build a decision ops team, which is involved in having a domain expert and the decision automation specialist, and still is a team, still requires cross collaboration, but it doesn't require the whole IT team in software development practices, business analysts, software engineers, solution architects, DevOps for deployment, data engineers, integrator, and QA to do everything that they need to do generally to build a solution to automate and manage decisions at scale in your organizations. Now, what I'm going to do is I'm going to jump off to the platform and I show you how a decision can be modeled, a role can be modeled, how you can deploy them, how you can debug them. And we're gonna have some fun in the car insurance example scenario for pricing. And to do that, I need to stop sharing and share it again, my screen. So bear with me for a moment.
Okay. That's fantastic. As I said at the beginning of the webinar, there is a QA box on the bottom of the Zoom application. We'd love to hear from you if there is anything that you'd like to cover at the end of the demonstration. That would be great. And I can see that Arash is sharing his screen.
Excellent. I'm trying to minimize the Zoom toolbar. So let me stop and share it again.
Not a problem. Yep, Arash, I can see your screen.
I'll leave it here so we can deal with it later.
Yeah.
Excellent. So what I want to start with, because we talked about the importance of the decision and how we can make hierarchical, complex decisions and all of that. Let's start with the decision at this point. So in this particular scenario, we're talking about calculation of the eligibility score for insurance of a car. And I can see there is a typo here, so I fix it. So what you see on the screen is a decision graph. A decision graph is a way to decompose a complex decision to a smaller decision unit. So calculation of the score, as you can see at top of the screen, requires some data input. Those data inputs are pink rectangles, round rectangles around the screen. Now, the way you can read and understand this decision graph is to look at the decision graph as a way to model dependencies. So the way it works is you can say, at top of this graph, I highlight in red, to calculate the eligibility score, you need the auto eligibility and you need the driver eligibility. If you look at the driver eligibility, you can see we have age category, decisions around age category, and we have drivers recording category. And if you look at the auto eligibility decision, which is this one, you can see it is connected to another node. So it requires rating from this particular node. However, as I mentioned, decisions can be hierarchical, and this particular node has different shape and color. And what that means is this is a hierarchical decision. So you can drill down to this decision and see how the rating is working. Now, this is, again, another decision graph, and the hierarchical decision means a decision can be nested behind another node of decision and can be nested behind another node of decision. So it's a nesting of another entirely decision graph within an existing current decision graph. Now, if I go back here, again, once you model this decision, you can see you don't need to talk about anything other than a decision. You don't need to focus on rules. You don't need to focus so much on the structure of the data and anything. This can be a very easy way to understand how the decision is made to calculate eligibility score, right? Now, if you drill down to any of these nodes, they are either connected to a decision logic, i.e. can be a predictive model from PMML or rule-driven model from a type of business rules modeling, or can be connected to a orchestration model which simulates, for example, another way of modeling decisions using more complex process flow model, or can be connected to another decision graph, which is the hierarchical decision concept. Now, if we go to the risk rating, what you're going to see is this has two other sub-decision units. To calculate the rating, we have theft category and we have occupant injury category. If now we drill down to occupant injury rating, you can see something similar to Excel. This is not by accident, this is by design, and that's the reason it's simple and easy to use flex rule, because you can leverage your existing knowledge. If you know how the Excel works, you can definitely create and manage and deploy rules using decision table. So in a decision table, green columns are condition, pink column is an action. You can have as many as condition and as many as action that you want. In this particular case, let me select a row and tell you how that translates to a rule. This row that I selected says if the car has driver's airbag because the value is true, and has passenger airbag because value is true, and doesn't have a side panel because this is false, then occupant injury rating is low. So selecting a row in a decision table will construct a rule based on conditions, green column, and actions, pink column. There are other ways of modeling business rules. If I open this one, what you're going to see is an editor that allows you to write rules. This type of rule modeling is called natural language, and the reason is you can build your business glossary and business terminologies. You can establish a ubiquitous language in your domain, i.e. insurance, and then you can use them to build your business rules. And we call it natural language because you naturally can read through it. This highlighted section is called rule number 1, R1, and it says, when car is convertible, then theft rating is high. You can see it's very easy to understand for everyone, and it doesn't require any programming languages. Even building these types of rules is easy because it is guided with the suggestion box that you can select, and it provides the value for what you selected, and you can select the options that is valid for that particular scenario. So it has a context about the rules and about what is going to happen in specific scenario. And if I close it, you can see we're back to a sub-decision graph. And if I close that, you can see we're back to the actual main decision graph that we started. And similarly, in every node, you can drill down and you can see different nodes doing different things using decision graph or using rules, or even if I select a node here, you can see you can have a predictive model imported from your PMML. Your data scientist team build an algorithm, statistical algorithm, regression, classification, whatever it is, and you can import it here as part of the decision graph and integrate that, that predictive model as part of this decision-making scenario. Goli, are we good? Do we have any questions so far?
Yes, we have questions, but I will keep it for the end of the session. But very interesting one.
Awesome. Now, that's all good in terms of designing decisions, but how is it different from doing it in Visio or Paint or whatever you're doing on the whiteboard? The big difference is if you do it in FlexRule, these are not just graphical, beautiful, easy to understand models. They are executable. You can go live and start debugging them and start understanding how they behave step by step. You're in control. So in this particular scenario, we have 3 data inputs: driver information, car information, and client segmentation. So if I drill down to the type of the information we need, you can see another model that specifies how the car information is structured, or in the other instance, how the driver information is structured. And you can see there are some of them, it's very small, but are highlighted here. There are some icon identifier behind them that it says this particular field of information within car or within driver information has some constraints. So you can manage your constraint about the information, if they are required, if they're mandatory, if they're not, if they're within certain range and all of that. And you can import, for example, JSON schema to build that automatically, or you can build it simply with drag and drop and setting values of these fields. Once all of that is set up, let's go and have a look at how the debug simulation mode works. Now you can see yellow arrow, yellow highlighting here, which I highlighted with the red rectangle. Now this yellow arrow, yellow highlighting is the step of execution, meaning that we're about to execute this particular decision. And I say decision because this is linked to another decision graph. Now, you are in control if you want to see all the details of that, or you want to skip this one and you want to go to the next one. So I go here and I say, yes, I want to go to the details. You can see it navigates with you. You are in full control how detailed you want to go. So I want to execute the next one. I say, okay, yes, let's execute this one. You can see now, it goes to natural language. It executes all the rules one by one. And if you see the yellow arrow, yellow highlighting, that means this particular rule number 2, which is saying price greater than 45,000, match the criteria of the input car, and it's been executed. We go one by one again. We are back to the decision graph, and it's going to ask us, do you want us to execute this specific decision, potential occupant injury category? Do you want to see the details? Okay, yes, why not? Let's go to the details of that. Now you can see again, the yellow arrow highlighting comes with you, and I'll show you how you can skip it in a minute, because if you have a complex decision, you're probably running too many of those decision rules. You don't want to run all of them every time. You want to find where the issue is. Actually, you can put a breakpoint here saying, I want to run it and stop at this particular rule and see what the problem is this. But we didn't do that, so let's run it. And now we are back to this stage, and we are back to the decision, the main decision graph. Now we can go to the next one. We don't want to see the details. And if I stop this, you can see now, based on this decision graph and the rules we had, we calculated the eligibility. Now, what is interesting, when I talk about the decision orchestration, I didn't mean the decision graph. Don't get confused. The decision graph, or if you're using DMN, decision requirement diagram, is a simplified version of the decision graph. They're not decision orchestration. They are decision modeling tools that allows you to model a decision. Now, decision orchestration is what you see on the screen. So you might need to have a database connectivity. So you can drag and drop a database here and connect to a database, or you might need to send a notification after the premium is calculated to a particular request. So you can drag and drop, and you can build this within all the tooling that you have in your place to build the orchestration around the decisions. Where are those decisions? These nodes that I highlighted are those decisions. The rest are orchestration around those decisions. So I changed this, I closed this, and I reopen it to see the original one. Now you can see in this decision orchestration model, we have a start point, and we have multiple termination node and successful end nodes. Start with the start node, which is this green circle. And at the beginning, we validate the input information. How do you validate them? It's very simple. We already defined the structure of the data that we need. So we just pass the information to here, and it does the validation for us. And once that is valid, data coming, we go to determine the eligibility score. If we drill down to this, this is another decision graph. I didn't go through this, but if you look at this in the middle, this is the decision eligibility score that we already discussed. So I close a couple of them, and I go back to this decision graph. The other thing is, now when you do a decision orchestration, now you can combine the data from different data sources. You can transform the data to the shape and form that you require for decision making, that is in the context of decision automation. And then what you can pass them to the decision graph to create the decision outcome, and then it returns back to your decision orchestration. Now you made that decision, you can integrate that into your organization systems and processes, post it to information system for the record, communicate it to the client, record it in the database, pass it for an audit. So the orchestration is a very significant piece in the decision automation and management practice. I'll just pause here.
Yeah, Arash, we have a question which I let me just bring it up. That would be a good question to answer right now, I guess, because someone put in the chat that being in the field of decision management for some time, we often face challenges from the latest hype, like AI, machine learning, and also IT is not often ready to let go the ownership. And I see the BI overwhelmed by having to learn something new as a tool. Have you faced similar challenges, and what are you done to overcome these challenges? And
yes, let me breathe. Hype are always hard to really ignore them, but the good thing is you can leverage them because you can have a activity in your orchestration layer for dealing with the hype to, for example, let's do that here, to communicate to ChatGPT and translate whatever you want to do with the ChatGPT. So you can use the orchestration layer as an AI orchestrator to deal with the hypes and integrate them as part of your decision-making process, right? The other part of it is, of course, it's very hard and difficult for IT to let it go. When we're talking about decision ops, it doesn't mean that IT does not have control. What it simply means that IT can have control with less effort. And it will translate that IT and software development team now can focus on more strategic opportunities for organizations rather than sitting them and do the plumbing, do the data query, create the data and deploy them as a services to be used in decision automation and all of that, right? And that person in the decision ops team can still be from IT, but rather than involving 6 senior staff of software development and IT, you can have an entry level or very mid software developer involved in the decision ops team to do all of this plumbing, because they don't need to have the knowledge and expertise in building systems and deploy them and test them using standard traditional IT approach.
okay.
Does that make sense? I hope. And if it doesn't, we're happy to take the discussion offline and continue on that.
There's also another great question: how to change the rules or add a new rule?
Oh, that's very simple. So the first thing is the rules were about the rules were in the context of a decision, right? Let's say in this particular decision graph, I didn't go through the details of this one, but we have a discount component. So if you drill down to this, from the shape and color, you can say this is another decision graph. It's a hierarchical decision. So we go here and we can see the discount component now has 2 parts. One is the car conditions discount percentage, another is the segmentation discount. So let's say for any of them, you want to add another rule or change the value of a rule. You go and find your rule. It's easier to find the rule using the decision navigation rather than going to a database of hundreds and thousands of rules and find what rule you want to change. For 2 reasons. One is finding nail the haystack is hard. Second is if you find it and if you change it, because in business rules management system point of view, rules, when you change it, you don't know the impact of that change. You don't know where it is used, how it is used, what other scenarios that are involved. But when you drill down with decision graph and decision approach, you can see now this particular rules involved in that particular decision. Now, let's say changing the rules for elite clients of $500 discount to $480. I just changed the rules.
Yeah.
And If you do that, then you can go back and see what are the other decisions that are using this particular decision logic. So you can find upstream and backstream usages of the decision. You can see this is only used in the client segmentation discount. So you are confident you don't break down any other part of the organizations because of this rule change.
Yeah, great. Arash, we still have 1 or 2 minutes to go through one more question, which is quite interesting. What is the difference between rule set and decision?
So rule set traditionally came from business rules management system, and it is simply a collection of the rules. And that's all it is. Decision, on the other hand, is a way to create an outcome for a specific scenario. It's a business question, how much this client is eligible for a specific product for a discount. This is a business question. Now, these business questions can be answered either with rules or can be answered with your predictive algorithm model, or can be answered with going to the database and querying an understanding of the information about the clients. It's not necessarily only rules. A decision might be satisfied with the combination of multiple algorithms and multiple techniques, and it can be hierarchical. They have relationship, and you can see in my screen, for example, this was a hierarchical decision. And if you had a rule set, you would need 1 or 2 rule set, all these rules sitting in them, and you couldn't have predictive model embedded into a rule set. But in the decision, it's hierarchical, it is multi-techniques, and they have relationships.
Okay. One more questions, I guess, Adrian received.
It's a great one. It's basically, what are your deployment options? So now you've built a rule or decision. How do you deploy it?
So it's very simple. You just go to the model you want to deploy, and you say deploy. And as simple as that, you can now deploy in many different cloud providers as a serverless model, or you can deploy to your infrastructure, whether that is on-prem or cloud, with a single click. So you select here, you say deploy, you put your Azure information or cloud information, AWS information in, and you press publish, and voila, it's become available to consume using a REST API endpoint.
Okay, fantastic. There is no more question for now, Rash.
Excellent. Thank you very much, everyone. I hope you joined us, and I'm sure you have still questions, and you can contact us definitely with information you see on the screen. Contact us info@flexrule.com, and we will be happy to answer all of your questions and have a private session for you to take you through more details based on your questions. Thank you, everyone.
Great. Thanks for joining us today. As Arash mentioned at the beginning of the webinar, there's a series of webinars that we plan. If you have good topics or any topics that you have in mind that you'd like us to cover, please contact us. We love to hear from you. Thank you so much.